Today we'll discuss about 1 mark questions in engineering graphics subject. See, here you have a question of 1 mark that is given in one question paper. A plane scale of 1:40 to read meters and decimeters, which is long enough to measure up to 6 meters, and find the length of a scale value of it. So this is a question. For this we need to find out the length of the scale. So for that, here see, first I'll write the given data. What is given here? RF value is given, that as 1:40. So RF, I am writing this as 1/40, and maximum length is given. See, long enough to measure up to 6 meters he is saying, right? This is the maximum length. Here see, we have maximum length is equal to 6 meters. Here we have. So here length of a scale is equal to RF into maximum length. So that here we have 1/40 into 6 meters. Here I am converting this meters into centimeters, so that 6 into 100 I'll get. So here if I simplify this, 600 by 400, here I have 40 here I have 600 by 40. So that here what it is going to be, it is 15 centimeters. So LS, length of the scale, is 15 centimeters we have. Now we have a second question. Draw the projection of a point capital A is 30 mm above HP and 60 mm in front of BP. Here is the question. First we need to write the reference line. Here XY we need to write first. The reference line we are taking here, this has a X and Y, and the next here is saying point A is 30 mm above HP. So above HP means we'll get above the reference line, in front of VP means we'll get below the reference line as per coordinate system. So directly I am writing here. I am not going to explain every term in the coordinate system, first coordinate, second coordinate, third and fourth coordinates. So simply I am taking here it is see, the point A 30 mm. We need to measure here from a 30 mm. Just taking a nominal lines here as the 30. I am taking this as just 30. Here this as just 60. And here we have a point A dash, and here we have another point A. I am taking here to here the distance is 30, and from here to here it is 60. Like this we need to finish for 1 mark. Third question, a line of AB of 80 mm is parallel to and 40 mm above HP and in the VP, draw its projections. This is a question. Here for this question also, first we need to take a reference line here of XY. A general reference line I am taking here, it has X and Y. Here is saying 40 mm above HP and in the VP is saying a line of AB 80 mm, actual length of the line is 80 mm, and is saying that the line is 40 mm above the HP and parallel to HP. So that here what we need to do is, from this reference line above, here we need to measure a 40 mm distance first. 40 mm distance we need to measure from this, and here I am keeping a point here first. Here 40 mm, here it is 1, and here this is a 40 mm. Next, based on this which is parallel to the reference line, here by using 80 mm as distance as I mentioned, see, from here I am taking a line of 80, so that is fine. And next from here I am joining this end with the same reference line, so that now it is going to be, this is A dash and this is B dash of points, and next the respective height is here from here to here, that as as 40. This is a 40 height, and A dash B dash length is, and that is going to be your 80 mm. It is going to be 80 mm distance here we have. So next thing is what we need to do. Here I am saying above HP is done. Next in the VP is saying, in the VP means on the reference line we need to write it as a line. Already we measured it as 80, so I am highlighting here, that is A and B. Like this we need to write for this line for 1 mark. And the next question, here we have a define prism and pyramid. See, here we have a definition that you can observe here. Prism is a 3-dimensional solid object in which the two ends are identical, and it is the combination of the flat faces, identical bases and equal cross sections. And this is the definition of prism here we have. Next, pyramid definition. Next definition of pyramid, here we have a pyramid is a 3-dimensional shape, and a pyramid has a polynomial base and flat triangular faces which join at a common point, and it is called as apex, and this is going to be a definition of a pyramid here. The next question, draw the projections of a cylinder of base diameter 60 mm and 70 mm long axis is resting on HP on its base. This is a question here. For this, here is saying that is on the HP. The base of a cylinder is saying it is on the HP. For this, see, I am constructing a casual view here. See, the thing is, first take a reference line of X and Y here, and the base of a cylinder is saying it is 60 mm diameter and 70 mm long axis. It is resting on the HP. The base is resting on the HP means under the reference line it will come. See, here you will get a base of a cylinder. It seems to be a circular structure, so I am constructing a circle shape here like this. Next we need to divide this into some equal number of parts. I am going to divide this into only 4. Here A, B and C, D I am using it. Next I am extending this corners here towards the reference line 1 and 2 and 3, and is saying the diameter of this that is what base of a cylinder is saying that it is 60. Why 60? It is 60. Okay. Next, here the axis is saying, okay, axis 70 mm long, so it will come above the reference line. Above XY line will get an axis of 70 mm. From here you have to measure a 70 mm axis first. It seems to be a rectangular shape. Next cylinder, and here can 1 and 2 and 3 and 4. Next here it is going to be 1 dash, 2 dash, comma 4 dash and 3 dash, A dash, B dash, comma D dash and C dash, and the height of this particular axis here is mentioned that as 70. Like this you have to represent the projection of a cylinder with a base diameter 60 mm and 70 mm axis long. The next question, what is the difference between the parallel line and radial line methods? Here we have a solution. See, that is the answer. Here you have a solution. Parallel line method is employed in case of prisms and cylinders in which stretch out line principle is used here. And radial line development is used for pyramids and cones in which the true length of the slant edge or the generator is used as a radius here. This is the difference between these two, parallel line method and radial line method here we have. Next question, what is the perimeter value of a pentagonal prism of base side 30 mm and axis 60 mm long axis he mentioned. So here we have how to find out perimeter value of a pentagonal prism means, here we have a pentagon, we all know we have 5 equal sides. So each side is 30 mm is saying, prism of base side 30 mm means each side is having 30 mm. So that what we need to do here is 5 sides, 5 into 1 each side is 30 means 30 plus 30 plus 30 plus 30 plus 30, 5 30s. It is going to be 150. This is the perimeter value of 150 mm is the perimeter value of a pentagonal prism. Here we have. The next question, explain the views in case of first angle projection. This is the question here. In the first angle projection, the views come in the following sequence. Here I am going to write here. The first thing is the answer here. How it will come in, the views come in the following sequence here. First is top left, then clockwise, then the right view, then front view, comma, and the top view. This is a sequence order that we have views in a case of first angle projection. Here we have. Similarly, as we just now discussed about the angles, the views in a case of first angle projection, the next question he asked here, explain the views in case of third angle projections. The same thing. Here I am going to write the answer. This is for 1 mark question, that's why I am writing in a short. In third angle projections, first thing is the top view. It seems to be the top view sits at the top of the front view, and then the right view sits on the right side of the front view. Here it is going. And this, the top view sits at the top of the front view, comma, and the right view sits on the right side of the front view. This is the view that will come in a case of a third angle projection here.